We're not going to be looking at velocity time graphs. We're going to look at two examples. First one's quite a straightforward, simple one where you're looking at drawing the graph, working out the acceleration and finding the total distance covered. And the second example is slightly more tricky, so we'll look at that whenever we come to it. Okay, let's start off. A cyclist passes A with a speed of 2 meters per second. Immediately after passing A, he accelerates to 6 meters per second in 4 seconds. He maintains this speed until he passes B 3 seconds later. Part A, draw the velocity time graph. Part B, find the acceleration in the first 4 seconds. And Part C, find the total distance between A and B. Okay, so first of all, start off by drawing your velocity time graph. Remember, velocity on the y-axis, the vertical axis, and time along the horizontal axis. In terms of the scale here, well, this is the answer. In terms of the scale, it took 4 seconds to accelerate, and 3 seconds was whenever he passed B, so it was 7 seconds along. And the high speed reached by him is 6 meters per second. Now, at the beginning, at time equals 0, when he passes A, he is travelling at 2 meters per second. So at time 0, he's travelling at 2, so there's the first point you would plot whenever you draw your graph. It says he accelerates to 6 meters per second in 4 seconds. So 4 seconds, he reaches the speed of 6 meters per second. So that would be the second point you plot. And then finally, it says he maintains that speed for 3 seconds. Well, it's 3 more seconds, so it's going to take 7 seconds, and he's maintaining that speed, so that's going to be a straight line. So the graph will look like this. It will start at 0, 2, it will rise to 4, 6, and then it will go along to 7, 6. Okay, part B is find the acceleration. Now acceleration, because all the questions you're going to be doing in M1, the acceleration is constant, it's going to be given by the gradient of the slope. To get the gradient of the slope, it's rise divided by run. So in this slope here, the rise is from 2 up to 6, the rise is 4, the run is 4, 4 divided by 4 is 1 meter per second squared. So the acceleration is 1 meter per second squared. Okay, and finally is work out the total distance covered, or the total distance between A and B. So to do that, what you need to do is you need to work out the area under the graph. Now to work out the area under the graph, I would consider it in 2 separate parts. The first stage for that would be from time equals 0 to time equals 4, this trapezium. Now remember, the area of trapezium is given by half the length of the 2 parallel sides added together. So the 2 parallel sides of this trapezium would be this side here, 2, and this side here, whenever time, which would be 6, so 2 plus 6 is 8. Half of that is 4, and then times by the perpendicular height. The perpendicular height here would be 4. So the area of trapezium is 16. It's 2 plus 6 is 8. Half of that is 4, and then times by 4 the perpendicular height, which could be 16 meters. So this section is 16 meters. It was 16 meters he covered in the first 4 seconds. In the second stage of the journey, that would be from time equals 4 to time equals 7. Well, that's quite straightforward to get this area. It's just going to be 3 times 6, which is 18. 18 plus 16 was 34 meters. So the total distance covered is 34 meters. Okay, we're now going to look at a slightly more complex example. An athlete runs along a straight road. She starts from rest and moves with constant acceleration for 6 seconds, reaching a speed of 8 meters per second. This speed is maintained for t seconds. She then decelerates at a constant rate until she stops. She has run a total of 520 meters in 79 seconds. Calculate t, and that's the length of the constant velocity. Okay, well first of all, let's look at the velocity time graph. Here we've got the acceleration at the beginning from 0 to 6 seconds until she reaches a speed of 8 meters per second. Then she maintains this speed. This length here is then t. Okay, so from 6 until this value t, plus 6 actually, this would be t plus 6 because you've got your 6 to begin with. And then this bit here, the constant velocity of t, so this would be t plus 6. And then from this point here, t plus 6 all the way until 79 seconds is her decelerating. So what we need to do is we need to work out the length of time that she was maintaining this constant velocity. Okay, well, we're given a clue. We're given the total distance covered is 520 meters. So what we're going to do is we're going to look at the area of the first stage, the area of the second stage, and the area of the third stage. And those 3 areas will add together to give you 520. So let's work that out. Okay, let's consider the first stage. But the first stage is the first 6 seconds. That's quite straightforward. The base of the triangle is 6, the height of it is 8, half base times height, 3 times 8, 24 meters. So this stage 1, 24 meters. Okay, stage 2. Well, that's from time equals 6, and she maintains this for t seconds. It would be from 6 all the way up to t plus 6. So because she maintains it for t seconds. And the height of it is 8. So the whole length here would be from 6 up to t plus 6, so the length of it is t times 8, the maximum speed was 8, so t times 8 is 8t. And finally, the last section, this is the third stage here. Now, the height of it is obviously 8, the base would be from t plus 6 all the way up to 79. So what we're going to do is for this length here, it would be 79, take away t plus 6. Well, that would give you 73 take away t. And it's half the base, half 73 take away t, times 8, which would be 4 times 73 take away t, which would be 292 take away 4t. And now, stage 1 plus stage 2 plus stage 3 will equal 520, the total distance covered. You just add those together, you'd work out what it is, you get 4t equals 204, so t equals 51 seconds. So the length of time she maintained that constant velocity was 51 seconds. So that means that for the first 6 seconds she was accelerating, for the next 51 up until 57 seconds she was then maintaining that velocity, and then for the remaining 22 seconds she was decelerating.